To begin with, we are starting with the team from Wipro. They are going to talk about greener optimal laminar flow tipping valve. The presenters are Mr. Biradar MG and Mr. Pushant Kumar. Biradar MG is a mechanical engineering graduate with 29 years of experience in the field of design and development, specializing in truck tipping systems.
Biradar is not actually available today, so Mr. Vinayak will be presenting along with him, along with Pushant Kumar. So you can just introduce Pushant Kumar.
Okay, yeah. So Pushant has received his BTech degree from JNTUA in 2009 and MTech from the same institution in 2014. He's worked as a new product development engineer at UCAN India. Since 2021, he's working as R&D project leader in design of hydraulic pumps and control valves for tipping systems at Wipro in Infrastructure Engineering. So he's having a total experience of 13 years and 9 years of that in hydraulic valves and pump. So welcome Pushant and please go ahead.
Good afternoon. So today's topic is on the tipping valves. Generally we given the name, instead of tipping valve, we given a different name. Like what are the features we achieved in the valve, for that reason we given a different name, like greenery, optimal, laminar flow, tipping valve. These are the features we achieved in the, These are the features we achieved in the new design of tipping valve. So generally, just for abstract, a tipping valve is used in the tipping application for lifting and lowering the tipping body to unroll the material. The valve is combination of both direction control valve and pressure relief valve, the tipping valves. So typically, generally operates the tippers is working with wide range of flow rates, and why? Because there is no speed control at the time of tipping operations. Because of such reasons, the relief valve has to be in a flatter relief curve. Based on this, the pressure relief valve is one of the most important type of safety valve. It reduces excessive pressure in the hydraulic system to safeguard the systems. And in this new valve, we got a best performance characteristics and low discharge, that means low pressure drop between the ports, and we will get a laminar flow. And the features which we accomplished in the new valve, which is the average pressure drop across the ports is very less. It is around very less in a single digit, I can say. And we get a flatter relief curve which is very flat. It is around 15 bar in higher RPMs. And there is a marked reduction in the flow temperature decrease, as it results the less heat generation in the system, and it prolongs the lifespan of the system. So we introduced a new 100% pull-proof tamper system in the valve. Hence, once it exists from the manufacturer, we can't able to change the relief system, increase or decrease in the particular valve. Hence, it safeguards the complete system and also parallel to the operator. And we achieve the high pressure drops, high pressures in less flow rate, because we can it leads to decrease the consumption of fuel in the tipping operations. So these valves looks like. This valve consisting of a pneumatic chamber and a spring chamber and valve and the spool. Here we given the two options of pump inputs for the based on the customer requirements. So in this valve, we given it's a 3x3 valve. In neutral condition, the pump port is directly connected to the tank, where the complete flow is passing through from pump to tank in neutral condition. In this, we given a in the pneumatic chamber, we given a two ports, where one is for tip-up condition and another is for tip-down condition. Once if you activate the tip-up condition, the pump line is directly connected to the C line. By the time tank is blocked, along with the relief, the excess pressure from the system, it is released to tank through the relief system. And once you activate the lower system, pump line, cylinder line will connect it directly to the tank for down application. So just brief background and for the tippings, for the direction control valve and the tipping systems. So general direction control valve is a system to control the direction of the flow within the system. So it can controls the enables actuation of various hydraulic cylinders and motors. Typically have the direction control valve typically have multiple ports and multiple pathways that configure to different circuits. And direction control was configured with configures including spool valves, puppet valves, and rotary valves, etc. Direction control valves is combined with different mode of operations like manual, electrical, and pneumatic. In some conditions, we can go for automated controls also. So these little background of the tipping valve system, we are focusing on this. The control valve is widely used in the tipping system where the mechanism that controls the flow from pump line to flow controls through the hydraulic to actuator to hydraulic cylinder responsive for raising the cylinder or body or lowering the body. In this direction control valve, we introduce the pressure relief valve for preventing the overshooting pressure in the system and controls overloading conditions and to prevent the damage of the hydraulic system. Pressure relief valve is once set pressure is reached, pressure relief valve is activated when it reaches to the set pressure. This I'll hand over to Vinayak.
Good afternoon. So here you can see the typical circuit of the hydraulic system, where the main components of telescopic cylinders, control valve, and there is one CCV, that is a cabin operated valve. So where the operators operate from the cabin, and these are the overall piping layout, where you can see the there is a suction from tank suction, it goes to pump, and from DCV, when the operator operates, the truck driver, you can see the tip up, tip down, or when the operator keeps in neutral position, the cylinder will remain in the holded condition. So in this, the control valve is very important, because if the control valves, spools, etc., there is any movement during the operation, the cylinder will try to come down or go up. So control valve function is very important, and this the development what we recently did, from shifting from old valve to new valve. There we have introduced the very good flow handling capacity and pressure drops curve, which will help us, our end users, our customers, so that the heat generations will be lesser and even the diesel consumption will be less. So that's why we have given this name for the greener laminar flow valve.
So with the old valve, we have a certain list of issues, because the tipping system is using more wide range of RPMs and wide range of flow rates. Because we are facing load issues at lesser RPMs, that means lesser flows, and second is high back pressure at high LPMs, and overshooting relief pressure at higher flows of higher RPMs. There is no significant space of RPM maintenance in the truck. So they can operate from lower RPM to higher RPM, which is around 700 to 800 at lower RPM, that means ideal, and full throttle it is around 2200 to 2500. There is no control in RPMs now. So this is the valve looks like. These are some features of the valve. The flow handling capacity of the valve is around 200 LPM max. And as of now, the release system we are providing for the applications is 190 bar. And the spool movement with the pneumatic supply, it can use for 4 bar to 12 bar. And the pump and tank port combinations we can get at 3/4 and 1-inch BSPs. And the cylinder port is SAE standard, where it lands on the SAE port is, the valve is completely land on the cylinder. So these are called some improvements in the parts in the valves. So this is a non-return valve which is providing in the pump line, where the return line flow will not hit to the pump for the damage. So in this we increase the area of flow by 40%. We did a lot of DOEs. Based on the DOEs, we conclude that 40% is the right percentage to increase for the maximum flow of 200 bar. And coming to in the valve block, for the better laminar flow, we increase the flow galleries around, in the tank line, we increase around 125%. So coming to the spring, we generally a lot of DOAs comes in picture in the time of making the spring design, because once it springs with higher flows, it gives higher pressure. Instead of getting higher flows and higher pressure, we introduce the spring like, if it is the pressure is low, that means around 30 LPM to around 160 or 200 LPM, the pressure will be just delta P of 15 bar. So that we introduce the new spring with a new design. We are using the grade 2 material for the spring manufacture. And we increase the input flow for the relief system, where we increased by 100%. There should not be any turbulence to input to the flow, to the relief system. That is the reason we increase the flow to area to 100%. These are some calculations for the spring. We made it. And in spring, the maximum stress we taken up for the higher LPM is max 25 to 30%, that's it. So we given some of the modifications in the body and also parallelly in the spool, where we introduced a lot of chamfers, where it can move, it can flow easily. There is no sudden restrictions in the flow. So we introduced chamfers in the spool and parallel to the body, and we calculated the steady state force and parallel to this transverse force also. So these are one of the feature we introduced in the relief control wall for pull-proof system. There should not be any adjustment of the relief controls once it reaches to the end customer. For example, if they are overloading condition, they try to increase the spring pressure to get the more to increase the more stress in the spring, they'll get more pressure. That should not happen, because of it becomes a safety issue for the system and also driver and everything. So because of this reason, we introduce a grub screw at the time of, once it gets set to 190 bar, as of now we are giving for the tipper system for 190 bar. So at this position, we lock this relief adjusting screw with a grub screw, and above that we are packing within solid piece. There should not be any change further anymore once it exits from the manufacturer. So once any issue it comes to the relief system, it may be an issue with the manufacturer or whatever, we need to scrap the wall. There is no changes can be done in this system. And coming to this existing wall, we make the same wall in tipping systems. We have two types of mountings, where one is cylinder mounted and another one is the tank mounted. In the same casting, we made a modular design which suits for both the applications. Like one is for cylinder mounted DCV, and this is for tank mounted DCV, where we remove the flange, excess flange in the C port, and we introduce a new flange in the tank port, so it can use for both applications. And these, the rough images can able to see. This is called the tank mounted wall, and this is the cylinder mounted wall, and this is tank mounted wall with an attached flange for the system. And coming to the comparison between the existing wall and the new wall. So there is the graph is representation, one is with pressure with respect to the flows. And in roughly we are getting 30 LPM to max 200 LPM in the tipping trucks. It is maybe come from 30 to 160 also, or it may reach us to 200 also. Based on the highest flow rate, we made the testings. So this blue line represents the old wall, and the green line represents the new wall, which in the old wall, at the initial stages, we are getting at 170 bar, and peak at 200 LPM, we'll get 240 bar. So there is this delta P of 70 bar. So it is not good for the system to shoot up the pressure up to 240 bar. It may chance of failing the pump and system too. So because of this failure, we are introduced a new wall with an input. At the lower LPM, we will get 185 bar, and the peak we will get 210 bar. Max to max, we will get 25 bar. This is the lab validation graphs. And this is the just overview of the graph, which is taken from the HIDAC outputs, where this is the green line and blue line represents the pump line and cylinder line, which is almost inline to both of them. So based on the new wall, the pressure drop between both the pressure drop is very less. It is 10 bar, less than 10 bar. The relief characteristics is more found. It's flatter, means higher pressure load at lower RPMs enable operator to lift more load without accelerating the RPM. With this new wall, operator can operate the tipper with the ideal RPM, that is around 800 RPM. There is less consumption of fuel by that time. If the operator operates with a higher RPM, there is a consumption of high fuel. So also full throttle RPM relief system spikes max to max, it's 210 bar. This will reduce the heat generation in the system and enhance the lifespan of the system. These are standards we represent for making the new designs. Thanks.
Thank you, Pushant and Vinayak. Any questions for them, please? Anybody?
Yes, please.
Mr. Seshnath.
Yeah. It was very intriguing that you mentioned that you switched over from a circular cross-section to an oblong cross-section.
Yes, sir.
Are you still able to achieve laminar flows with that?
Yes,
because
definitely.
it could show
we
some
are increasing the area of the flow now, sir. So we can achieve the laminar flow there. We are definitely increase the flow, increase the area, we'll get free flow over there.
Yeah, but what was the concept in moving to oblong?
So because of space constraint, we are making 2 oblong holes. That's it.
Thank you.
Thank you, sir.